Let's review what we've learned in a previous lesson about limiting reactants. Dead giveaway. You are dealing with limiting reactants if you are given the amount of more than one reactant. How to find the limiting reactant? First, calculate the number of moles of each of your reactants that you have. Second, divide each of those numbers by the respective coefficients in the balanced equation. And thirdly, the reactant having the smaller result from step 2 is the limiting reactant. And once you have found the limiting reactant, every subsequent calculation must begin with that limiting reactant. Let's try another problem. We're given a balanced equation here. We're given a mass of iron that we have and a volume of chlorine gas. And assuming conditions are STP, we want to know which is the limiting reactant. So let's use the process outlined on the previous slide. Let's convert each of these reactants into moles. From the periodic table, 1 mole of iron is 55.8 grams of iron. That's about 4.0 moles of iron. And again, I always write the word have below that, because that reminds me that that's how many moles I have to start with. Chlorine, we're talking here liters, which is volume of chlorine, and at STP, 1 mole of any gas occupies 22.4 liters of space, which means that we will have 8.0 moles of Cl2. The next step says take each of those numbers of moles and divide by the respective coefficients for those substances that are from the balanced equation. At the top of the screen we see that the coefficient for iron is 2, the coefficient for chlorine is 3. I'm going to calculate those numbers. Obviously 4 divided by 2 is 2, 8 divided by 3 is 2.66. The smaller of those two tells me which reactant is limiting. Now, once we have calculated these numbers, in this case 2.0 and 2.66, we're never going to use those numbers again. Their only purpose is to tell us which one the limiting reactant is. If we're then asked what mass of iron 3 chloride is produced, we're going to, like Austin Powers, behave and start our calculation with the amount of limiting reactant that we have. And since we've already calculated moles of iron, we're going to start right here on this island, which, not coincidentally, has the name moles of iron. So to get from that island to grams of FeCl3, we need 2 conversion factors. So here we go. 4 moles of iron, 2 bridges to cross, so 2 conversion factors. The first bridge, we're going to take them in order, see? The first bridge requires us to use the coefficients in the balanced equation. Of course, there's a 1-to-1 ratio, moles of iron to moles of FeCl3, but I went ahead and put 2's there because those are the actual coefficients that are in the equation. You can put 1's there if you want. It doesn't matter because you have the same number of moles, top and bottom. But we did put moles of iron on the bottom for sure. Then we're going to use the periodic table to help us figure out the molar mass of FeCl3. We've got 1 iron, which has a molar mass of 55.8, and we have 3 chlorines, each of which has a molar mass of 35.5. You add all that up, you get about 162.3. Rounding to 3 significant figures, we get an answer like this.